Welcome! In this tutorial series, we will make a Flappy Bird game using the Godot game engine. If all goes well, we will have a game like this at the end. I expect you to have some programming experience, and also you should know the basics of Godot in order to follow along with these tutorials. Let's go ahead and start creating Flappy Bird. Welcome! In this first part of the Flappy Bird series, we'll do some setting up. First, we need to import our assets. Next, we'll do some configuration in the project settings. And finally, we'll create our main game scene, which we will call World. I'll see you in there. I've created an empty project, and first, let's import our assets. I've included a link in the description which you can use to download them. And once you do, you'll have a zip folder inside your downloads. So just right-click and extract. Once you do that, you can just drag and drop them inside Godot. But first, let's go back to Godot and take a look at our import settings. Because if you don't change your import settings and you just import them like that, they're gonna be imported as regular 2D textures. But our textures are pixel art, so we need to specify to Godot that we're using pixel art. To demonstrate this, you can click on the icon.png which you have inside your file system, drag it inside the scene, and if you zoom in, you can see that it's a bit blurry. The pixels aren't very clear. Let's click on icon.png, make sure it's selected, go to the import tab, which is next to the scene tab, and change the preset to 2D pixel, and click on re-import. As you can see, now the pixels are much more clear. This is what we need to use to import our assets. So let's go to preset again and set this as default for texture so that Godot uses this preset for every texture it imports. Now we can go back to downloads and drop our assets inside our project. Inside our assets folder, we have textures that we need. We have a font that we're going to use to count our score. And finally, we have some audio effects that we need. Okay, next, we need to go to the project settings to do some configuration. Here, I'll go to Window, which is under Display here. And I'm going to set my display size to 480 by 854, which is a good size for mobile games. And I'll scroll a bit down and set my orientation to portrait instead of landscape. This will ensure that our game is displayed in the portrait mode when we export to a mobile device, which is important for our game because we're gonna be developing it for a portrait display. Next, I'll set my stretch mode to 2D and my aspect to keep, and this will ensure that my aspect ratio remains the same even if I resize my screen and even if I run my game on a device that has a different aspect ratio, a different size. And next, I'll go to quality, which is under rendering, and I'll turn on use pixel snap, which is a useful feature if you're making a pixel art game. And finally here, we want to go to pointing, which is under input devices, and turn on emulate touch from mouse. Okay, we're done here. So let's close and let's actually go to the scene tab and let's delete this icon that we used for demonstration purposes, and let's scroll back up. And as you can see, the blue line, which represents our camera, changed because we changed our display size. Finally, let's create our main game scene. To do that, let's go to the scene tab and let's click on 2D scene here, which will create a basic node 2D, which we will rename to world. Let's hit Ctrl+S to save this, and I'll just save it inside the res folder. And let's add a sprite node to display our background. I'll rename this to background and go to my assets, textures, find the background, drag it inside the texture field under my sprite. By default, it's centered. The offset is in the center, but let's change that. Go to offset, just unclick centered, and the offset will start from the top left. And it fits perfectly. You can zoom in and first turn on pixel snap, then try resizing it, and as you can see, the blue lines are just on top of our image, which means that it's perfectly fitting our display size. Let's save again, and we're done for this tutorial. Okay, that was some setting up to do. I know it's not very fun, but it's necessary in order to start making our game. And these settings will be different depending on the type of game you're trying to build, and that will come with experience and by making different kinds of games. For example, if we weren't making a pixel art game, some of the settings that we used would be different and things like that. So yeah, congratulations on starting this series. In the next section, we'll start building our player character. I'll see you in the next one. Bye. Welcome. In this tutorial, we'll start creating our player character. This will be done in two parts. In this first part, we'll create the player scene, and in the next one, we'll create a script and start implementing the functionality. Without further ado, let's get into it. Okay, we're back. First, I'll create a new folder to store my player scene. I'm gonna create a folder called characters. And inside characters, I'll create one more folder called player. And in this game, we're only gonna have one character, but for some reason, if you decide to add more characters, you can add them under this folder. Next, I'll create a new scene. And this scene will have a rigid body 2D as its root node. We'll call it player. Let's add a sprite and a collision shape 2D. I'm gonna drag my texture into the sprite, and as you can see, my texture is actually a sprite sheet which has all the animation frames that we need inside of it. For that reason, I'm gonna go under the animation and set my horizontal frames to 3. Next, I'm gonna create a shape for my collision shape, and I'm just gonna use a regular old circle shape here. About up to here. Next, I'm gonna add an animation player. And we're only gonna need 2 animations for our player. We're gonna create an idle animation, and that's gonna be played before we start flapping. And we're also gonna have a flap animation, which we're gonna play once we start flapping. I'll create the first animation, call it idle. This is gonna be autoplayed, and it will also loop. So for idle, I'm gonna animate the position of the sprite to give like a flying effect to the bird. And to do that, let's go to the sprite nodes, transform property, and let's set the Y value to -5. And we'll key this. And let's click on 0.5 on the animation timeline, and let's set the position Y value to 5, and let's also key this. If you start the animation, you can see that it's going up and down, but it looks a bit rigid. We want it to look more fluid and smooth, so let's set the interpolation mode to cubic. And as you can see, it's much more fluid. It looks better. Now let's start creating the flap animation. For flap, we're just gonna animate the frame property of our sprite. So I'm gonna create a new keyframe, and I'm gonna key the next 2 frames as well. And oops, this has to start from 0.1, 0.2. Okay, and this is actually gonna take only 0.3 seconds, and this will also loop. If we start the animation, you can see that our bird is flapping. But as you can see, the position of the sprite is messed up because of the idle animation that we just made. Idle changes the position of the sprite, but let's say we stopped the animation here. Clearly the sprite is in the wrong position, but nothing is actually fixing this. Once we switch to flap, flap isn't correcting the position of the sprite. That's why at the beginning of flap, we need to set the position back to 0, 0. So I'll just reset the position and create a keyframe here. And now if we switch to idle, play, stop, the sprite is in the wrong position. And if we go back to flap, boom, it's back in 0, 0, which is what we want. Finally, let's save our scene, which I sometimes forget. Under characters, player, save, done. And this tutorial is also done. We created our player scene, we added the nodes that we need, and in the next tutorial, we'll start writing some code and implement the functionality of our player. I'll see you in the next one. Hey, welcome back. In this tutorial, we're continuing off where we left off last time. We will start by adding the player to the world scene, then we'll create a script and make our bird start flapping so that it can be an actual Flappy bird. Like this. I'll see you in there. Okay, this is where we were last time. And first, I'm gonna go back to the world scene and instance my player so that I can see it in the game. I'm gonna place it right in the middle, and my display height is 854, so I can just divide it by 2 here inside the editor, and that should give me the exact middle of the screen. And I'm just gonna move it towards the right a little bit, and about here is fine. Let's say 115. And now if we run the game, first you probably have to select the main scene. I already did, but you're probably gonna have to select world as your main scene. So do that, and let's run this again so that we can see that the bird is actually falling down. And that's because the rigid body has a gravity scale, and the gravity scale defines how strong the gravity is affecting the rigid body, and in this case it's just 1. So let's go back to the player scene and set this to 0 for now. We'll change it in a bit. And now if you run the scene, run the world scene, you'll see that the player is just standing in the air and the idle animation is being played. Now let's create a script and attach it to the player. This is going to be an empty script, and we'll just say create. Before we start writing any code, let's define an action inside the input map. that we'll use when the player wants to flap. And we'll detect the left mouse button for this action. I'm gonna check inside my physics process if this input action is being pressed or not. And we'll use just pressed instead of pressed. And let's define a start method that we'll use when the player flaps for the first time. Because right now our gravity is 0 and we want to set the gravity to something else, to a positive value once we start flapping. Let's also define a started boolean that we'll use to check if the game has started or not. And inside start, if we started, just return because we don't have to do anything. We can't start twice. And if we didn't start yet, let's set started to true. And let's set the gravity scale to 5. Let's get a reference to our animation player first. And let's play the flap animation. Because remember, we're playing idle when the game first begins. We don't want to play idle once we start flapping. Oops, I said animator.flap. That's funny. Animator.play flap. I've set this gravity scale to 5 because gravity scale of 1 is just too weak and it takes a while for the player to fall down actually. So 5 is better in this case. And we only want to call start if the game hasn't started yet. Now let's define our flap method, which we'll use to make the player move up. Let's think for a second. What do we want to happen once the player flaps? We want the player to move vertically up, and at the same time we want the player to rotate counterclockwise because we want the player to look up when we flap. And likewise, we want the player to start rotating clockwise once we stop flapping because we want the player to look down once it starts falling. And the gravity will take care of falling part for us. Okay, great. So let's define a flap force variable. And I'll define this as export so that we can change it from the editor. And we'll set this to 200. Actually, negative 200. Has to be negative because we're moving up. And inside flap, we can use the linear velocity property of the rigid body, and we'll set the linear velocity.y to flap force. We don't need to change the horizontal velocity because our bird isn't actually gonna move, and instead we're gonna make the obstacles, the pipes, move towards the player. Now let's run the game and see what it looks like. I haven't flapped yet, so I'm inside the idle animation and the gravity is 0. And if I start flapping, as you can see, the gravity is set to 5, so the bird starts falling. And we set it to 5 because 1 was too slow, but as you can see, 5 it's decent. And every time I click, we're running the flap method and we're setting the linear velocity to the flap force variable we defined. Awesome. Now the only thing we need to do is rotate the player so that it looks like it's flapping up, and once it's falling, it looks like it's falling straight down. We can achieve this by using the angular velocity property of the rigid body. Now to demonstrate this, let's set the gravity to 0 even if we flap. Let's actually comment this line out, and inside the flap method, let's set the angular velocity to something like 8. And now if I flap, I'm actually gonna move up because I still have the linear velocity set, so I'm also gonna comment this out. And now once I flap, my angular velocity will change my rotation. Each time I flap, the angular velocity is changing the rotation using the amount I set it to. But as you can see, positive values are actually spinning us in the clockwise direction. So let's set this to -8 instead of positive. And let's run it again. And let's also actually print our rotation so that we can better understand this. Oops, if I can type. Let's also print our... it's fine. As you can see, at the beginning our rotation is 0, but if I click, it changes and it settles down at -85. So we don't want our player to keep spinning like this because it's gonna look very funny. So let's set a limit to how much the player can spin. Let's define a constant up here, and I'll call this max rotation degrees. And we'll set this to -30. Has to be negative because we want the player to rotate counterclockwise. Okay, now after we call flap, let's just check if our rotation degrees, which is the rotation our rigid body has, if it's less than or equal to max rotation degrees, we'll set the angular velocity to 0 because we don't want to rotate anymore, and we'll set the rotation degrees to max rotation degrees. Oops, I didn't use an assignment operator there. Okay, let's run the game and see if it works or not. And as you can see, let's also comment these out so that our gravity works again and the linear force is applied. So now, as you can see, the player can't rotate more than our max rotation degrees. Let's delete this line, clear the output, and the last thing we need to do is when the player is falling down, it needs to start rotating and look downwards basically. And to achieve that, we can use the rotation degrees again, and we can check our linear velocity. And if our linear velocity is greater than 0, that means we're falling. And if we're falling, we'll check if our rotation is greater than 90, and if it is, we'll stop rotating because that's the limit we want. If linear velocity dot y is greater than 0, and if rotation degrees is less than or equal to, if it's less than or equal to 90, that means we haven't reached the limit yet, so we'll keep rotating. So we'll set our angular velocity to 3. And if we reached 90 or we're over 90, we want to stop. So we'll say else angular velocity is 0. So now if you run the game and flap a couple of times, and as you can see, the player falls down head first and it doesn't rotate any more than that. And you can actually comment these lines to see what it looks like if you don't have that. And as you can see, it keeps rotating and it doesn't stop. Okay, I'm gonna go back to my world scene to take a good look. And in this tutorial, we added a script to our player and made it so that the player changes animations once we start flapping, and the player can move up once we click the mouse button and rotate accordingly. So this is it for this tutorial, and I'll see you in the next one. Welcome! In this tutorial, we will create the ground scene for our game. It's very simple. We're only gonna create a static body with a sprite and a collision shape. And at the end, I'll also show you how you can create a scrolling effect like this using a sprite and an animation player. Let's get started. Let's create a new scene. This is gonna be a static body. Oops, not a 3D static body, it's gonna be a 2D static body. Let's change that to static body 2D. And I'm gonna call this ground. Let's save this, and I'm gonna create a new folder called environment. And this folder is gonna have our ground and stuff like pipes and any other scene that we create that's related to the environment. Save it, place it here. Okay. Now I'm gonna add a sprite and a collision shape. And for the sprite, let's drag the ground texture. Ground.png. We don't want it to be centered, the offset to be centered, so let's uncheck that. And let's create a collision shape. And we'll just use a rectangle shape. Let's resize it. This is gonna be a bit tricky. Make sure you get it right. Oops, it's a little too big. Okay, perfect. It's okay if the collision shape doesn't cover what's outside the display size. We're never gonna be able to go there anyway. In fact, we're never gonna there will never be a collision from under the shape anyway, so we could just make it just a pixel tall, but this looks better in my opinion. Doesn't really matter. Now before we animate the ground, let's go back to our world scene and let's instance the ground. I'm gonna quickly turn off the collision shape so that it looks a bit more normal and save it. Let's move it down to where it belongs. I'm holding shift as I drag so that it moves directly down and it doesn't move left or right. It's a handy little trick. And let's place it here. Okay, so now if we play the game, it looks fine, but it looks very static and it's not moving. We want it to be scrolling. So let's go back and let's add an animation player. So what we're gonna do to make it so that it looks like scrolling is we're gonna animate the position of the sprite. So we'll take the sprite and we'll key the initial position, then we'll scroll it to the left like this, and then when the animation ends, it'll snap back here and it will keep doing this. But there's a problem. As you can see, once we scroll, there's a gap here inside the display now. And if you go back to world, you can see that the background is showing up. We don't want that. We want the sprite to be wide enough so that even if we scroll, it covers the whole display. Oops, let's put this back to 0, 0. And what we want to do is we want to scale the texture so that it's wide enough. We could also go inside Photoshop and copy and paste this and make this twice as long, and that would also work fine, but in this case I'm just gonna scale it on the x-axis by 1.5, and now it is wide enough that we can animate it. Let's create a new animation, call it scroll. This is gonna auto play and loop, and it's gonna be a second long. So first let's key the initial position, and at the end we want it to be, the trick here is, okay, first let me show you what happens if I just randomly scroll it. I'm just gonna scroll it about this much and key this and play. And here you can't really understand it, so let's go back to the world scene and let's play. It's not a very smooth scrolling effect because once the animation is over and when it starts over, it goes back to here again, and the pattern isn't the same anymore. So we can track any one of these stripes to get a better understanding of this. So at the start, the first stripe or part of the first stripe looks like this, but at the end it looks like this. It's not the same. We want this to be the same so that when it snaps back to here, like this, when it snaps back, it should be the same so that it looks like it's seamlessly transitioning. So let's delete this keyframe and let's do this again. So I'm gonna take a good look at this stripe, excuse me, and it looks like there is 1 pixel gap here, and let's keep that in mind and let's start scrolling the sprite. But make sure that you're not scrolling so much that it ends and you can see the background. So let's, okay, I think this looks good. So let's check, let's go to the beginning, and it looks like this, and at the end, oops, I forgot to key. Make sure you key before you start experimenting. So, okay, let's do that much. Oops, too much. Okay, now let's key this, and let's get closer, and boom. Yep, looks the same. So now if I scroll, you can also test it in here if you get close enough. Yeah, it looks good. Looks like it's, if I were to see this and I didn't know that this was being animated, I might think that it's actually infinitely, there's like an infinite track. Let's go back to the world scene and see how it looks. Nice. So let's also try to see if the collisions are working, and perfect, it's working. Okay, cool. In this tutorial, we made the ground scene, we animated it so that it looks like it's scrolling, and we made it so that our animation looks smooth. Thank you for watching, and I will see you in the next one. Bye. Hi everyone, in this tutorial we'll start working on the obstacle scene. This is gonna be a short one. We're only gonna create the pipe scene. And in the next one, we'll start working on the pipe spawner scene. Our game is starting to look like an actual game. I'm very excited, and let's get started. let's go ahead and start by creating a new scene. This one's gonna be an area 2D. And the reason we use an area 2D instead of like a rigid body or like a kinematic body is we only want to detect when the player touches a pipe, but we don't necessarily want to calculate any collisions between those objects. Because in the original game, once you touch a pipe, the player just falls straight down, and there's no collisions. You just fall straight through the pipe. And that's why we're using an area 2D. I'm gonna call this pipe. I originally called this pipe, but if you're planning to make changes to the game, and by changes I'm talking about maybe using different textures and maybe adding other stuff and making it different from the original game, you might want to call this something else, because if, for example, you change the pipe texture to a tower, for example, I don't know, it's not gonna look good if it says pipe in the class. And that's why I decided to go with a more generic name, and I'm gonna call it wall. You can call it whatever you want as long as it describes what it does. And it's basically a wall. It's a moving wall, but I'm just gonna call it wall. This is gonna have a sprite and a collision shape. For the sprite, let's use our pipe texture. And I'm gonna move it down just a little bit, and this is gonna make it easier later on when we're doing some calculations to randomly generate these. I guess it's gonna make it easier. I just feel like it makes it easier for me. So yeah, and I'm gonna add a rectangle shape that covers about this much. It's not gonna be perfect, and we're not trying to be perfect and like include this 1 pixel section as well. You could by using a polygon instead of a collision shape 2D, and you could use I think it's called a collision polygon 2D, yeah. Or you could use 2 collision shapes, but it's not that important. It's not really gonna make a difference. Okay, that looks fine. Let's save this under environment. And everything is looking good. Okay, I told you that this was gonna be a short one. In the next one, we'll start using this scene and generating some obstacles for our player to flap through, I guess. Okay, I'll see you in the next one. Bye. Hello, welcome back. In this tutorial, we'll create the pipes scene. We're gonna be calling this one obstacle instead of pipes, because like I said, we wanna be more generic just in case you wanna decide to change some textures. This scene is gonna be used by the spawner scene, and in here, we're gonna have 2 pipes and an area 2D in the middle that detects when the player passes through. Let's jump in and get started. Okay, let's create a new scene. This is gonna be a node 2D, and I'm gonna call this obstacle. Let's save this under environment, and let's move this to the middle of the screen, which in this case is 427. We need to add 2 pipes or walls to the scene. I'm gonna duplicate this one by hitting Ctrl D, It's Command D, I believe, on a Mac, if you're using a Mac. And I'm gonna rotate the one that I duplicated by 180 degrees. We need to separate these because we don't want these to be touching each other, otherwise we're not gonna be able to pass through. So I'm gonna move the one in the bottom by 75 pixels down and the one on the top by negative 75 pixels. And that's gonna make it move up by 75 pixels. This number that you use to separate these is gonna make the game easier or more difficult depending on how much you make them separated and how much you make them close. So if it's too separated, oops, I pressed F5 by mistake. So if you make it too close, obviously it's gonna be very difficult, but if you make it too separated, it's gonna be very easy. So I experimented a bit and I think 75 is a good value to use in this case, but you're free to use whatever value you wanna use. Okay, we also need an area 2D that we'll call score area. And this is gonna detect when the player passes through an obstacle. So let's add a collision shape 2D. This is gonna be a rectangle shape and it's gonna look something like this. Now we also need a script on the obstacle class because we want the obstacle to move towards the left, and we also want to connect some signals from our walls and our score area, and we also want to emit some signals when the player scores. But before we write some code, let's go back to the world scene and let's actually instance an obstacle scene just to see how it looks. It's good practice to test and see how the scenes you're building looks like in the game. Okay, so I'm gonna run the game and yeah, I think this looks like a reasonable distance between the pipes, and the pipes are also not ending before the screen, so that's also good because if you move them too much here like this, for example, they're obviously gonna show up like this, and we don't want that. We want them to have enough texture that they don't show up, just like our ground texture. Okay, this looks good. I'm gonna delete this and let's actually keep it there for now. I'm gonna move this behind the ground so that it looks better. And let's go back inside here and take a look at our script. Let's start by making the obstacle move, and we're gonna do that inside the physics process method. Let's define a speed constant. And this speed is gonna be very important because we want the pipes to move in harmony with the ground animation. Because if the animation is too fast, it's gonna look like the pipes are sliding, and vice versa. If the pipes are moving too fast, it's gonna look like the ground is sliding, so it's not gonna look good. So let's start by giving 200 for the speed and see how it looks like. I'm just gonna get the position.x value, add the speed, and it's gonna be negative speed because we wanna move towards the left. I'm gonna multiply this by delta so that it remains the same speed even at different frame rates. And let's say if our global position x is less than 200, which means that we've left this scene. So if we go back to world, this y-axis is 0. Excuse me, it's 0, 0 here, x and y. And if we go past this, that means we're going in the negatives. And if our x value is negative 200, it means that we've exited the screen and we've actually covered some distance. So if that's the case, let's delete our pipe and let's also print a message and let's say bye. This should make the obstacle move, and this should also delete it once it exits the screen. Let's run this and see how it looks like. And you can see that it's moved and left the screen, and once it did that, after a small amount of time, it ran the queue-free method and printed bye. And you can test this by going inside remote here. Remote will show you what's inside your current build of the game. Local will show you what's in your scene. Remote will show you what's inside the game that's being played inside the window. So here inside remote, we don't have any obstacle scene because that scene got deleted. But inside local, we have it because this is what's inside here. Okay, so let's actually not free the pipe, but rather reposition it to 500 so that it keeps coming back, and that way we can more easily test how it looks like compared to the ground. So it looks good. It doesn't look like it's sliding off the ground. Just to show you, I'm gonna set this to 100, set the speed to 100, and as you can see, the pipes are too slow compared to what the ground seems like moving. So it looks like the ground is sliding under the pipe, the obstacle. So I'm gonna set this back to 200 and actually set this to 215, which I found to be like the sweet spot. If you run this again, you can see that it looks smooth and it looks like they're moving at the same speed. Awesome. That's the movement part. Now we need to connect some signals from our walls. If you go back to the player scene, we can see that our player is a rigid body and our wall is an area 2D. And area 2Ds have signals that detect areas and bodies entering and exiting the perimeters that we define for them. Because our player is a body, we're gonna connect the body entered signal of the walls. And because both walls just kill the player, we want to connect them to the same function. There's no point creating different functions to do the same thing. So I'm going to connect wall 2 to the same function as well. Change this to wall so that it's the same. And in here, first, we want to make sure that the body that entered this area is the player. And to do that, we can do something like if body is player. But this isn't gonna work yet because we need to go back to the player script and add this line under the first line, class name player. And that way, this check works. And inside here, we wanna check if the body has a method called die, which we didn't define yet inside the player, but it's fine. And if it has, we want to call it. So this will make sure when the player enters the wall is going to check if the thing that entered is the player, and if it has a die method, and if it does, it's going to call that method. So let's actually print here to check that if we're successfully detecting the player. I'm gonna play, the wall is gonna move, and we're detecting when the player enters the wall because we're printing the message inside our output. Okay, nice. That's it for the walls. And finally, let's also check when the player not enters, but exits the score area. And let's actually make it a little bit bigger. And for walls, we want to detect when the player enters, because once it enters a wall, we instantly want to kill it. But for score area, we don't want to check when it enters, because that's going to be too instant. Like the player's going to just hit here, this part, and he's going to score. We don't want that. We want the player to score when it exits here. And that's why we're going to connect the body exited signal. And inside here, again, we want to check if the body is the player, and if it is, let's emit. Well, first we need to define a signal up here called score, and inside here we'll emit this signal. Okay, great. Let's also print just to test whether it works or not. Let's say player scored. Okay, let's run this, and yep, if I go up, if I don't go through it, it's not gonna say player scored, but if I go inside, it's correctly checking the player. Great, so let's go back. We don't want this to set the obstacle back to 500. That was just for testing purposes, so I'm just gonna set this back to Q3. And let's take a final look at our class. And everything looks good. You can delete the obstacle from here if you want to, because in the next lecture we'll actually create an obstacle spawner class that's gonna continually spawn these obstacles towards the player. Awesome, so I hope this lecture was helpful to you. We created our obstacle scene, added our walls, our pipes, whatever, added a score area and a script to make the obstacle move and detect the player. Thank you very much for watching, and I will see you in the next one. Hey there! In this tutorial, we will create the spawner scene. This scene will instance and randomly place obstacles so that the game looks different every time we spawn an obstacle. Let's jump in and get started. Okay, we're here where we left off. First of all, I'm gonna get rid of this print statement. We don't need it anymore. And let's create a new scene. This is gonna be a node 2D, and we'll call this one obstacle spawner. Let's save it under environment. This isn't gonna have too many nodes, it's only gonna have a timer, and we'll set this timer to 1.5 seconds, and this timer is gonna define how long is it gonna pass in between each obstacle. So in this case, a new obstacle will be instanced every 1.5 seconds. And we'll set this to auto start for now. It's not going to be like that in the actual game, in our final product, but right now it's easier for us to test things if it starts automatically. Let's add a script. This is going to be an empty string, create. Let's get a reference to our timer so that it's easier to reference to it. And let's also preload our obstacle scene that we made in the last lecture. I'm gonna connect the timeout signal of the timer to this script. And inside here, let's first define a method called spawn obstacle. And let's call this method from the timer's timeout signal. Inside this method, we want to instance a new obstacle. Instance. And we want to add it as a child. And we also want to randomize its position so that we don't get the same pipe location every time. And to do this, we want to change the y position of its position. And we will use the rand_i method to get a random number. We're gonna use the modulo operator and say 400 and plus 150. I'm gonna explain how this works and what it does in just a second. I'm actually gonna do it now. But first, let's go to up here and create a ready method, which we'll use to call the randomize method. Okay, so the randomize method makes sure that we get different random numbers every time we run the game. If you don't call this randomize method before you call random I, you're always gonna get the same random numbers every time you play the game. So let me show you this by getting 3 random numbers before calling randomize. And the way random I works, you can actually go inside the documentation by holding the control key and clicking on the method, and it will take you to the definition. And there's a handy little explanation here. As you can see, it says returns a random unsigned integer, use remainder to obtain a random value in the interval. So, and here we have an example. So if you just say random I and call the method, it's gonna return a crazy integer, crazy large. We don't want that. We want to limit this, and the way you do that is with the modulo or the remainder operator. So if you say randi remainder 20, it's gonna return a number between 0 and 19. So this number is not inclusive, I don't know what's the word. But yeah, this is how you use it. And in here, we're gonna use it to get, let's say for a number between 0 and 3. And let's copy and paste this 3 times. If I run this by pressing F6 to run this scene, not the main scene, this scene, I'm gonna get 1, 2, and 3. So if I run it again, it's gonna be the same, and if I run it again, it's gonna be the same. If I copy and paste it again one more time, it's gonna be 1, 2, 3, 0, and if I run it again, like I said, it's gonna be the same because we're not randomizing, so it's always giving us the same random numbers. They're still random, but they're always the same, which makes sense but also doesn't make sense at the same time. So let's see what happens if we call randomize before calling these randi method. Let's run it again, and as you can see, we get a different set of numbers every time we run, which is what we want. We don't want the game to look the same every time. Great, now that we understand what randomize does, let's come back to line 16 and try to understand what this statement is achieving. So we're asking for a random number between 0 and 399, and we're adding 150 to that. So we're basically getting a random number between 150 and 550. So we can add a little comment here that says get a random number between 150 and 550. And the reason we use 150 and 550 is this. If I show you this inside the world scene, you're gonna get it better instead of me just trying to explain it and do a poor job. So let's go back to the world scene. And in here, let's instance an obstacle. So by default, it will be on 427 on the Y. So let's move this to the right a bit and let's start changing its Y position. So we said 150 and 550, right? So first let's try 150. And as you can see, this will be the maximum amount that our pipes can go up. So if you go more, first of all, you start seeing the background here, and that's not good. And at the same time, if you move this 2 up, it's gonna make the game that much more difficult, and it's not gonna look that good because the upper pipe is almost invisible. So I experimented a bit, and 150 seems to be a good value, but this is gonna be a decision that you need to take for your game. And likewise for the bottom one, 550 is gonna be the maximum position, maximum amount that we can move our obstacle downwards. Great, so let's delete this obstacle and go back to our obstacle spawner scene. This method is gonna spawn an obstacle and randomly place it on a location that we defined the limits of, and the timer is gonna fire off every 1.5 seconds the timeout signal, and this method will be called. We are almost done, so let's create a couple of utility functions that we're gonna use to call the timer from outside this scene. And these functions will start or stop the timer. That's it. Okay, everything is looking good, so let's get back to our world scene and let's instance the obstacle spawner. We want this to be, if by default it's on 0, 0, but if it's here, it's gonna start spawning the pipes here and you're never gonna see them. So let's move this to the right. And I'm just gonna say that it should be at 800. Let's run the game. And if we did everything right, we should get pipes spawning at different locations every 1.5 seconds. But as you can see, we can't see the pipes over the ground. We don't want that, so let's take the obstacle spawner and let's move it behind the ground. Let's also take the player and move it to the front. In Godot, the things in the scene tree that are downwards, like in the bottom, will be displayed above other things. So we'll display the pipes, then the ground, then the player. Great, let's run it. And awesome. You're getting randomly placed pipes every 1.5 seconds. Great! You learned a lot in this tutorial and I hope it was useful. Thank you very much for watching and I will see you in the next one. Hi! In this tutorial we will create the HUD scene. The HUD scene will have a label that we will use to display the score, and we will update this label every time the player scores. Let's get into it. Okay, I'm gonna create a new scene and our HUD is gonna be a canvas layer. And under here, well, first let's rename it to HUD. Here we need a label that we will rename to score. This score label is gonna display what the current score is. So for now, let's put 0 as like a temporary score. Let's change the layout of this to top wide and let's pull it down just a little bit. Now we don't want the text to be starting from the top left. So let's change the vertical alignment to center and the alignment to center and the vertical alignment to center as well, so that it sits in the center peacefully. Okay, the next thing we're gonna do is to change the font. We don't want to use this ugly default font that Godot has. So let's create a custom font. You can see that there's a custom font property under the control section here. If you click that, you'll see that we're not currently using a custom font. I'm gonna click on empty and create a new dynamic font, and I'm gonna set the size to 48 and the font data to our font that we had inside our assets. That looks better, but let's add some outline to this so that it looks more like the original font that Flappy Bird uses. To do that, let's go to custom colors and check font color shadow. And you can see that already we have some drop shadow going on, but we want this to be an outline instead of a drop shadow. So let's go to custom constants and set the shadow as outline to 1. And this is gonna turn the drop shadow into an outline. Let's make this a bit thicker, 3 on the horizontal and 3 on the vertical. Good, okay, looks better. And now, let's save the HUD, might as well, under a new folder that we're gonna create called UI. And let's also save the font that we just made, the font resource, the dynamic font that we created, into a new folder, which I'm gonna create now. And that's gonna be called fonts. Let's right click on the dynamic font resource and click on save. And I'm gonna call this one Flappy Font 48. Great. Now let's add our script. And inside here, let's get a quick reference to our score label. And let's define a method called update score that we will use to update the score label. Make sure that you transform the new score variable into a string, because we're gonna be passing an integer to this. So we wanna turn it to a string first before we assign it to the text property of the label, because it's expecting a string. Great, so we're done here. So let's go back to world and instance our HUD. I'm gonna move it back to the bottom because it's in a canvas layer. It doesn't really matter where it is inside the scene tree. So that's why I'm gonna move it back. Now we have our HUD. We have a way to update the HUD's score label, and now we need to actually do it. And that's why we need to add a script to the world scene. And the world scene is gonna hold our game score. We'll also add a setGet method to this, and you'll see in a second why this is useful. Let's define it real quick. Okay, let's also get a reference to our HUD and our obstacle spawner. Now that we have our reference to our HUD, let's also update the HUD after we update the score variable that we have here. Great, so the useful thing here is the setGet method, which we called setScore, will be called every time we set score to a value. So every time we set score, the HUD will also be updated. So we don't need to call HUD.update score every time we change the score. Now let's create a method that we're going to use to update the score when the player actually passes through a pipe, and we'll call this player score. And we'll set this score, we'll increase it by 1. Make sure that you use self.score, otherwise the setGet method that we defined isn't gonna work. This is only the case when you're trying to set the score inside the same script. If we were to use set the score variable outside the script, the setGet method would be called, but inside you need to say self.score. And now the problem is we need to remember the signal that we set inside the obstacle scene, the score signal. Now we need a way to connect this to the player score method that we just created. But this method is inside the world script, but this signal is inside the obstacles script. And we don't have access to the obstacles inside the world scene. Do you remember what has access to the obstacles? Yeah, the obstacle spawner. So we need a way to communicate to the world scene that we want to connect the score signal to a method inside world. And that's why we're going to create another signal inside the obstacle spawner called obstacle created. And we'll pass the obstacle to this signal. This will be called after we spawn an obstacle and we set its position. Let's pass in the obstacle. And back in world, and inside the world, as you know, we have access to the obstacle spawner because it's inside the scene. And now, inside the ready method, when the game starts, we can say that we want to connect this method, this signal that's inside the obstacle spawner, to a method that we're going to define inside this script. And let's call it on obstacle created. And this has the obstacle inside. And the only thing we want to do inside here is to connect the score signal of this obstacle to, you guessed it, the player score method that we just defined. Let's run this real quick and see if it works. And if we go through, oops, something went wrong. At operants, player score. Oh, I think it's because we didn't set the score to anything. So let's say that it starts off as 0, and let's run it again. Now when we go through an obstacle, you can see that our score is being updated. And if we miss it, we don't get a score. Okay, great, so that works. So let's do a small recap because that felt a bit confusing to me. So inside the obstacle scene, we have a signal called score. And the score is being emitted each time the player exits the score area that's inside the obstacle. this area right here. Every time the player exits this, the score signal is being emitted. And inside the obstacle spawner, every time we spawn a new obstacle, we have another signal called obstacle created. We're emitting this signal and we're passing the obstacle. So back in the world scene, at the start of our game, we're connecting the obstacle created signal to a method called onObstacleCreated, and inside that method, we're connecting the score signal of the obstacle to player score. So this is all work that we did to basically connect the score signal of the obstacle to this method right here. If you didn't really understand this, please don't hesitate to ask a question. I'll be happy to help. Now the final thing I'm gonna do is to create a new game method that we're gonna use to start the game. And inside here I will set the score to 0 and I will call the start method of the obstacle spawner. And we'll call this method after we connect the obstacle spawner signal. If you remember, inside the obstacle spawner, we set the timer to auto start. Now we want to uncheck this because we're starting it inside the world script. But this isn't going to behave differently because we're starting it right away anyway, but later on when we create our menu system, this is going to be useful. So let's run the game and see if this whole thing works properly now. I can go through obstacles and my score is being updated. And if I miss, well, we don't have a game over state yet, and we don't have that die method that we defined, that we said we will define inside the player. So that's why we're not actually dying. But as you can see, the HUD works and we can score. Okay, great. Thank you very much for watching this lecture. I hope you learned something useful, and I will see you in the next one. Welcome! In this tutorial, we will implement the game over functionality. We will define a die method inside the player script, and we will stop the game once that method is called. Let's get started. Okay, let's handle the player death functionality. But first, do you remember the method that we tried to call from the obstacle scene? The die method that we said we were gonna define it later? Let's take a quick look at that before we get into the player script. And you might have noticed that I'm using this quick open scene window to navigate between scenes. The way you open this is by holding down Control and Shift, it's Command on a Mac, and pressing O. Then you get this window, and from here you can see all the scenes in your game. And if you have a ton of scenes and you don't want to look through all of them, you can just type it out here. I'm just gonna type obstacle and press enter, and here I am. Okay, cool. So inside the script here, when a body enters any of the two walls, we're checking if the body is the player and if the body has a method called die, and if it does, we call it. So now we will define this method, because up until now, because we didn't have this method, this condition, the second one wasn't met. The first one was, because we were in fact colliding with the player, but the player never had a die method, so this was never true. But now we will define the die methods, so this condition will be called. Let's go to the player scene, and in here let's create a new method called die, and in here we want to do a couple of things. First, let's create a signal that we will call died, and let's emit this inside the die method. Okay, the second thing, we of course want to stop animating. We don't want to keep flapping when we die. So let's get the animator and call stop. We also don't want the bird to be able to flap anymore. So let's create a variable that we will call alive, and let's set it to true by default. And let's check once the player presses the flap action. Let's check if are we also alive. And if we're not gonna call flap. And inside here we'll set alive to false. And at the start of this method we'll check if we're not alive, let's return, because there's no point calling a die method if we're not alive to begin with. We can also add a little print statement here to test if our die method is working or not. But before testing, right now the only thing that's calling the player's die method is the walls, the pipes, as we call them. But we also want the ground to call this method when the player collides with it. So let's go to the ground scene, and in here we want to be able to check if the player enters this body or not. And to do that, let's add an area 2D, which we will call death zone. This is going to have a collision shape 2D, and for this collision shape I'm going to use the same shape resource from the collision shape of ground. I'm going to right click, copy, get back to death zone shape, collision shape, and paste. Let's quickly position this. Okay, but be careful, because once you copy a resource, that resource is being shared among the two collision shapes. So if you resize one, the other will also get affected. If you don't want that, you can right click and click on make unique on either of them to make them independent of each other. I'm not going to do that because they're going to be the same size anyway, so there's no point. But just to demonstrate, you can see that once I start resizing one, the other is also being resized. Okay, great. Now we need to hook the body entered signal of the death zone to a script, and inside there we will call the die method of the player. But the problem is we don't have a script on ground that we can use, and we could add a script to ground, or we could also add a script to the death zone, which is also a good idea. But I'm just gonna go back to the world scene, and in here I'm gonna turn on editable children on the ground, and I'm gonna hook the body entered signal to the world script. Great, and in here we'll do the same checks that we did inside the obstacle. If body is player, and if body dot has method die, we'll call body dot die. Great, now we're correctly calling die both from the ground and the obstacle. Let's run the game, and if I just fall, whoops. Okay, I made a small typo there. You probably noticed it before me. Let's add a T there, and let's run this again. If I just fall, I died. I can't, even if I click, I can't flap anymore, and our print statement also worked, which is good. So let's get back here, let's delete. Let's also check one more time to see if the die method is also working with the pipes. Yep, works, great. So we set alive to false, and that's why we couldn't flap anymore, because we're doing a check after we get input. Our animator also stopped, and we emitted this signal here, which we will use later on. Let's get rid of the print statement here, and let's go back inside the world script. Here, after the player dies, we want the game to stop. To do that, let's connect the died signal that we're emitting from the player to the world script. And in here, we wanna first, we're gonna do a couple of things here, but first let's actually create a method called GameOver, just for simplicity's sake and just so that it's easier to read. Let's create a GameOver method, and in here we'll first stop the obstacle spawner. Then we need the ground to stop as well. So we'll get the ground. Well, first let's get a reference to it. We'll say ground get node. We'll get its animation player. This is a nice way you can get a node inside a scene if that scene doesn't have a script and you can't create a reference. This is a way you can use. And we'll say stop. And finally, we want the obstacles that are currently on the screen to stop. Because by default, as you remember, our obstacles are moving towards left. But once we die, we don't want them to move anymore because we want to give the impression that the game stopped. And to do that, let's go inside the obstacle scene and let's add this scene to a group that we will call obstacles. And inside the world scene, we'll use the call group method of the scene tree to call a method on a group, and in this case the group is obstacles, and the method we want to call is set physics process, and we want this to be false. This method will deactivate the physics process method of every scene that's inside the obstacles group. Let's take a quick look at the obstacles script. And here, as you can see, we're making it move inside the physics process. So once this method gets deactivated, the obstacle won't be moving anymore. Let's run the game and see if this is working. So if I just jump on the ground, everything should stop. Good, that's working. Let's also try with the obstacle. Okay, great. This is it for this tutorial. We implemented the game over functionality, and in the next one, we will create a menu system that we will use to display a game over menu and a simple menu before the game starts. Thank you very much for watching, and I will see you in the next one. Hi there! In this tutorial, we will create the start and the game over menus. Without further ado, let's get into it. Let's go to our world script and let's comment out the line where we call new game. We don't want the game to instantly start anymore. We want the player to tap once or click the mouse for the game to start. I'm gonna hit Ctrl K and comment this line. And now let's add a new canvas layer to the world. This canvas layer is gonna hold our different menus, and we're gonna call this one menu layer. Let's move this next to the HUD layer and let's turn this into a scene. We're gonna store it under the UI folder. And let's go inside that scene now. This is gonna have two menus, as I said, and these menus are gonna be control nodes. The first one we'll call start menu, and the next one will be game over menu. These will be both laid out as full rects. Now let's start with the start menu. This is going to be much more simpler than the game over menu. It's only going to have a texture rect. And we'll call this one start message. Let's go inside our assets folder and let's find the message.png file right here. I'm going to drag this over to the texture property of the texture rect. Cool. And now let's align this to this center and let's move it up like that. Now to find the perfect position for this, let's go back to the world scene and let's take a look at how it looks. It actually looks fine. That's lucky. I'm gonna run the game now and take a look at how it looks. Looks fine. Might be a good idea to move it down a bit, but for now I'm okay with this. I'm not gonna spend time tweaking it. You can do it on your own if you really want to. Now let's add a script to the menu layer. And in here we want to check when the player first taps the mouse, clicks the left button, and then we want to send a signal to the world scene for it to start the game. I'm gonna define a signal called start game, and inside the input method I'm gonna check if the event is the Flappy action that we defined. And if it is, let's emit the start game signal. But the problem with this is every time the player flaps, this will be called. We want this to be called only once. And that's why I'm gonna create a boolean up here called game started. And this is gonna be false at the start. And if flap was pressed and the game isn't started yet, let's emit this signal. And after that, we'll set game started to true. And we should also hide this message. We don't want this message image to be shown after the game starts. And to hide this, I'm not gonna delete it. I'm just gonna turn down its alpha down. So under visibility, you have what's called the modulate property. And if you click on this, you get this color picker kind of thing. And in here, if you turn down the alpha all the way down, you can see that the image disappears. So this is what we're gonna do. We could just turn off visible here like this, but we don't want the disappearance to be that drastic. We want it to slowly fade out. And to do this, we could use an animation player, but I want to show how you can do it with a tween. Let's go back inside our script and let's get some references to our nodes. I'm gonna first get the message. Let's get the tween. Okay, so after we emit our signal, let's use the tween to turn down the alpha. And to do that, we need to use the interpolate property method of the tween. This takes the objects that you want to interpolate the property of, and that's going to be the start message. Now we need to specify which property we want to interpolate, and that's going to be modulate. And we specifically want the alpha of the modulate. Next, the initial value, it's going to be 1, the maximum, and the final value will be 0, the minimum. And we want this to take 0.5 seconds long. Great. We also need to start the tween. If you don't call this method, nothing's gonna happen, so make sure you call this. And if you use the tween and nothing is happening, you might have forgotten to call the start method. Great, this will emit the start game signal once we flap, and this isn't gonna be called more than once because we have this Boolean variable to keep that in check, and we're gonna hide the start message image after we emit the signal. Let's go back into the world scene and let's hook this signal up. Let's go to the signal section of the menu layer and I'm gonna hook this signal to the world script. So when the start game signal is emitted from the menu layer, let's call new game. Okay, this should work, so let's try it out. Before we click, nothing is happening. The obstacle spawner isn't working, and if I click once, the start message is gone and the obstacle spawner starts spawning obstacles. Great. Now let's take care of the game over menu. Game over menu is gonna be a bit more complicated, but it's not gonna be anything too complicated, so we should be fine. I'm gonna hide the start menu for now so that it's easier to see what we're doing with the game over menu. Let's add two labels. First one's gonna be called the score label, and the second one is gonna be the high score label. Let's also add a button that we'll call restart button. I'm gonna hold shift and click on score label to select all three of these, and I'm gonna go to the inspector and set the custom font property to the font resource we created. Where is it? Where did I save it? Oh, I didn't save it. Oh, I saved it here. Sorry. Yeah. I meant to save this one, the font resource, in the fonts folder actually. I don't know why it's here. I might have to go back to that video and check, but it's supposed to be inside here. And I'm gonna drag this here, and now all these nodes are using that font resource. Great. Let's give these some text. This is gonna be called score, and I'm just gonna give it 0 for now just to see how it looks like. It's gonna be, let's call this best, and this one will be restart. And we obviously don't want them to be on top of each other like that, so let's create a VBox container and let's put all of these inside there. Great. I'm gonna get this bad boy and put him in the center first, then I'm gonna position him up a little bit. I'm also gonna hold down Alt, and I'm gonna make this box a little bit bigger, and I'm gonna go inside the labels and set the alignment to center. Let's also go back to the VBox and set the separation under custom constants to something like 20. That's maybe a bit too much, let's say 15. Okay, looking fine. Let's go back to the world scene to see what it looks like inside the game. Doesn't look too bad. Let's play it and see. If we die, this is what it looks like. Maybe we could position it a bit downwards, and let's add some outlines to the text. I'm gonna click on the score label, hold down Control or Shift. In this case, it doesn't matter. And click on Highscore label so that I have both selected. And I'm gonna go inside Custom Colors, turn on the font color shadow, and it's black by default. That's what we want. And let's go inside the custom constants, set the shadow offsets to 3, and turn on outline. Okay. And for our button, let's set its minimum size to, on the Y, let's set it to 75 so that it's a bit more taller. For width, I think what it has now is fine. Okay, great. I'm gonna connect the pressed signal of this button, and in here we'll do something, but first let's create another function which we'll call init game over menu, and this is gonna take a score. Let's get a reference to our score label and our Highscore label, which we're gonna use in a later tutorial. And let's also get a hold of the game over menu. Inside this method, we want to call this method when the player dies and we want to show the game over menu. That's why we have a score passed into this. This score will be passed from the world scene, and we're going to use it to set the text property of the score label. Let's turn it into a string. And we also want to, by default, this game over menu is going to be invisible. We're going to set its visibility to off, and let's turn the start menu back on, and let's say game over menu dot visible dot equals true. Great. And when we press the restart button, let's get the scene tree and let's call it reload current scene to restart the game. This is all the functionality the menus are gonna have. Now the last thing we want to do is go back to the world scene and make sure that we're showing the game over menu. So inside the game over method we have here, let's get a reference to our menu layer. And let's call it init game over menu function, and let's pass in our score. Okay, let's see if this works. I'm gonna die. We see the menu, that works fine. And if I press restart, the game's gonna restart. And let's try to get some points to see if the score is working properly. And our score is 3, as you can see. We're not gonna do the high score in this tutorial. That's probably gonna be the next one. But in this tutorial, we just implemented the menus and they're working fine for now, so I'm happy. Okay, great. Thank you very much for watching this tutorial. Make sure to like, comment, and subscribe if you want to see more tutorials like this. And make sure to take a look at my other videos. Like I said, thank you, and I will see you in the next one. Hi everyone! In this tutorial, we will implement Highscores into our game. We will learn how to save data and also how to load data from a file. Let's get started. Okay, let's go inside the world script and let's create a Highscore variable. This is gonna be 0 as default, and let's create a constant to store the path that we'll use to store our save file. We're gonna call this one save file path, and it's gonna be a string. And just like we have a res folder to store our project files, we have a user folder that Godot defines for us that we can use to store anything that we want to save on the player system. In this case, we're going to create a save file. I'm going to say user, and the name of the file is going to be save data.save. This user folder, the location of it is going to depend on your operating system, but I can show you where it is on Windows. Just go to your file browser, and in here you need to go to app data, which you can go by typing %, app data, lowercase, and %, and this will take you to app data roaming. And in here, you want to go to Godot, app user data, and from here you need to find the name of your project. In this case, it's Flappy Bird tutorial. And anything that you save or create from Godot, and anything that you save into the user folder is gonna appear here. Okay. This is gonna be our Highscore, and every time we die, we wanna check our score, and if our score is greater than this Highscore, we want that score to be the new Highscore. So let's go inside our game over method, and just before we call init game over menu from the menu layer, it's very important that you do this before you call this, otherwise you're gonna get some weird results. Just before that, let's say if our score is greater than the Highscore, let's set the Highscore to the score. Okay, now let's talk about saving and loading this into this Highscore variable. We're gonna need two different methods, which I'm gonna create at the bottom here. The first one is gonna be save Highscore, and the next one is going to be load Highscore. To save, we're going to have to create a new file, and we will use the path constant that we created to open our save file. Save data.open save file path, and we want to write to this file. The way this open method works is if the path you provided doesn't exist, meaning there's no file named savedata.save inside the user folder, this method is just going to create a new file for us. So even though at the start of the game we're not going to have a save data file yet, the first time we save, this method is going to create one for us. Let's store our Highscore variable using the save data's store var method. And this is it. So let's close it up so that we're done with this file. Now let's take a look at the load method. And this is going to be used for loading the Highscore at the start of the game. Just like saving, let's create a new file, but this time, before we open the path, we want to check if the file exists or not. So let's say if savedata.file exists, save file path. If it exists, let's say savedata.open save file path, and this time we're not going to write, but we're going to read from this file. The reason we have to check if the file exists in the load method is there's basically no point in trying to load data from a file that's empty. So if we don't check if the file exists or not, and if it doesn't, this open is just going to create a new file, and that's going to be empty. And we're gonna get some weird results trying to read some variable from a file that's empty. Okay, now let's set our Highscore to the variable that's inside this file that we just opened. And this getVar method is gonna read the first variable that we saved inside this file. And in this case, we only have one variable anyway that we stored here. And finally, let's close this file. And now we have to call these methods from the right places. So let's go back to the ready method and let's get rid of this comment here. And after we connect the obstacle spawner, let's say load Highscore, because we want the Highscore to be set before we start playing our game, and ready gets called at the very beginning of the game. And let's go to game over, and if we died and if we have a new Highscore, let's also say save Highscore. We don't want to call this if the Highscore didn't change, because there's no point saving it if it's the same. But if we have a new Highscore, let's go ahead and call save Highscore. This should work fine, but we also want to see our Highscore on the game over menu. But right now, we're only passing a score variable to the menu layer. Let's also pass our Highscore, and let's go to the menu script to add the Highscore to the list of parameters here, and let's set the Highscore label to this variable that we just passed. Okay, great. Let's run the game and see if it works. At the start of the game, I'm just gonna die, and our Highscore is 0 as we expect. Now let's try to get some points. 1, 2, that's enough. Okay, so score 2, best 2. Let's restart and let's die, and our best is 2. Looks like it's working. Now let's try to beat our best to see if it's updating or not. 3, yes, so now the best is 3, and just for good measure I'm just gonna play one more time, and I'm gonna get like, oops, I'm not gonna get any points because I was too slow. Okay, let's see if I can get to 2 and then die. And let's see, okay, my score was 2, the best is still 3. Seems like it's working. This is a really nice feature for our game, and I hope that this was useful for you. In the next tutorial, we will take a look at sound effects, which are really gonna bring our game to life. If you liked this video, make sure to comment, subscribe, and leave a like. And thank you for watching. I'll see you on the next one. Welcome! In this tutorial, we will add sound effects to our game. This is gonna be a short one, so let's do it. Okay, first let's take care of the player sound effects. I'm gonna open up player scene, and here let's add 2 audio stream players. The first one's gonna be hit, and the second one we're gonna call it wing. Now let's take a look at our assets folder, audio, and let's drag wing.wave into the stream property of the audio stream player. You can hit playing to hear what it sounds like, or before you drag it, you can double click on the wave file here and click this play icon on the bottom right. Cool, now let's drag the hit audio into the hits stream property, and let's go inside the script. In here, let's get reference to our hit and wing stream players, and let's play the wing sound effect inside the flat method, and let's play the hit sound effect inside the die method. Let's play the game and see what it sounds like. Okay, let's die. Okay, that's good. Now let's add the score sound effect. That's gonna be inside the obstacle scene. And in here, we want to play the sound effect when the player exits the score area. First, let's add an audio stream player. This is gonna be score. Should we call it score? Let's call it point, because the name of the sound effect is point.wave. Okay, I'm gonna drag the sound file just like we did before, and inside here, let's get a reference. And when the player scores, let's play this sound. Okay, cool. Now we have sound effects. I know I didn't use all of them, but if you really want to, you can use them too. It's very easy to implement, as you saw me do it. So if you want to use all of these, go ahead and create some new audio stream players and add these sound files into the stream and just call play. Okay, cool. This was a short tutorial. This is probably the last tutorial where we add new stuff and our game is basically done. In the next one, we will get rid of some problems that we have with the game, fix some bugs, and talk about improving our game. And I'm also gonna talk about what to do next after finishing this series, but that might be a separate video called Conclusion. Okay, thank you very much for watching, and I will see you on the next one. Hey guys, in this tutorial we will do some bug fixing. We will start by fixing the errors that we have here. Well, they're not errors, but they're warnings because they're yellow. This first one, the argument delta, is never used in the function physics process. This one is easy to fix. We just need to add a prefix before delta, and that one's gone. The next one, the function reload current scene returns a value. Well, we're not gonna use this return value, so there's no point storing it in a variable, so let's just ignore this one. Cool. Now if we run the game, we're not gonna get any more warnings. The next thing I want to look at is, I realized when we die, and if we die on a pipe, we still score, but we don't want that. Let me just show you real quick. See, I died and my score should be 1, but a score signal was emitted when it shouldn't. So let's go inside the obstacle scene. And in here, what happens is we score once the player exits the score area. But if we die on top of it, we can't exit from the right side, but we still exit from the bottom because it's very short. The fix is very easy. We just need to select the collision shape 2D of the score area and make it taller. And this much should be fine. Now if we play and we die on top of a pipe, we didn't score. So yeah, that's the fix. Okay, cool. The next thing I want to look at is, well, there are some impossible situations in the game right now. Sometimes we'll get a pipe that's very low near the bottom and the next pipe is very high. But our bird right now can't flap high enough in a single flap to reach that. So we need to increase the flap force of the player. And at the same time, sometimes we get a pipe that's very high and the next pipe is very low, and the player can't really fall fast enough because the gravity isn't strong enough. So let's first fix the gravity, because the gravity is going to affect the flap force, and we don't want to change flap force first because we're going to have to do some adjustments if we change it first. Let's look at the start method. We're setting the gravity scale here, and let's just set it to 10. Now if you play the game, you're going to realize that we can't nearly flap as high enough, and we fall much faster, which is what we want. Let me just turn down the volume a bit. Okay. And now we want to set the flap force to something higher, like 340. Now if you play, you can flap much higher in a single flap. And let's see if we can get a scenario like this. See, it was very easy for me to reach that. And like this one. Before we couldn't have done the sequence that I just got. Okay, cool. We got that, and the next thing I want to look at is the pipes, the walls. Their collision shape is too short, because what will happen is if we start flapping and at the start and we flap enough times, we can go over the obstacle and just keep going like that. Let me show you. So I'm just gonna flap like crazy at the start, and as you can see, I'm over the game basically, just scrolling through. We don't want this either, so this is also very easy to fix. We just need to go inside the wall, get the collision shape, and make it much taller. Like this. Let's position it like it used to be. Okay. This should fix it. And inside the obstacle you can see that it's a much bigger obstacle to go over. Let's test this. I'm gonna start flapping like crazy. I still die. Nice. The final thing I want to look at isn't necessarily a problem, but I just think that right now the player, when it's falling down, isn't rotating fast enough. So I would like the player to reach the maximum rotation faster. And that's why I'm gonna set its angular velocity once it starts falling to 5 instead of 3. And this way it's gonna look much more like the original game. Awesome. We did some bug fixing and some improvements to our game in this episode. Our game is basically done. Like I said, we're not gonna add anything else. And in the next episode, I'm gonna talk about what you might want to do next and my future plans. Thank you very much for watching, and I will see you in the next one. Hey guys, this is the end of the Flappy Bird tutorial series. Congratulations on finishing this series. If you found it useful, please subscribe, like, and leave a comment. I'm trying to improve myself as a content creator, so your feedback is very important for me. Stay tuned for any upcoming tutorials. I'm thinking of starting a new series very soon. Thank you very much for watching, and I will see you in the next one.